Hello everyone, welcome back to my channel Study Motivators. Last class we will discuss with problems on pre-tensioned prestress concrete beam. Now continue the problem number 2. Okay. A bonded pre-stressed concrete beam of rectangular cross section as shown in figure means in this figure we know B as a 200 mm and D as a 500 mm. Write the data. Solution: B equal to 200 mm and capital D equal to 500 mm. Okay. Next, the tendon is consist of 500 mm square area means AP. Area equal to 500 mm square. Next, it is pre-stressed to the 1500 Newton per mm square means FP. FP equal to 1500 Newton per mm square. Next, the tendon is located at the 100 mm from soffit of the beam means D dash. D dash equal to 100 mm. The tendon is located at the 100 mm from soffit of the beam and effective cover both are same. We will consider as D dash if FCK equal to 40 Newton per mm square. FCK equal to 40 Newton per mm square and EC equal to 35 kilonewton per mm square. EC equal to 35 kilonewton per mm square and ES equal to 200 kilonewton per mm square. ES equal to 200 kilonewton per mm square and find the ultimate moment of the beam means M. M equal to question mark. In this figure we know overall depth small capital D but we don't know small d effective depth means small d equal to capital D minus D dash minus D dash. Capital D is 500 mm minus D dash equal to 100 mm. We got small d as a 400 mm. Okay. Find the ultimate moment of the beam. Okay. Ultimate moment formula is FPB into AP into D minus 0.42 XU. In this formula we don't know two unknowns. First one is FPB value and second one is XU value. So step 1 let us calculate the effective reinforcement ratio. Formula is AP into FP divided by BD into FCK. Okay, we know AP as 500 mm square, 500 and FP value is 1500 Newton per mm square divided by B is 200 mm into D is 400 mm into next FCK value is 40. We got answer as a 0.23. Now from table 11 page 51 IS 4 2012. Okay. We got AP into FP divided by PD into FCK value as 0.23, but here not mentioned 0.23 value. So with the help of the interpolation we find 0.23 corresponding value. So 0.23 value corresponding value is 1. Again 0.25 corresponding value is 1. Now therefore 0.20 corresponding value is 1. 0.23 value is we don't know. Okay. Next 0.25 value is 1. With the help of interpolation we find 0.23 corresponding value. Okay. Let's see. 1 plus bracket open 1 minus 1 divided by 0.25 minus 0.20 into bracket open 0.23 minus 0.20. Okay, here 1 plus bracket open 1 minus 1 again 0.25 minus 0.20 bracket goes into 0.23. We want 0.23 corresponding value, therefore 0.23 minus 0.20. Okay, we got answer as 1. Now with the help of the interpolation we got answer as 1. Therefore FPB divided by 0.87 into FPU equal to answer as 1. Okay. Now FPB divided by 0.87 into Fy equal to 1. We got interpolation value is 1. Therefore we want FPB value. Okay. FPB equal to cross multiplication 0.87 into Fy into 1. Okay. 0.87 into FP value is 1500 given in question. 1500 into 1 equal to we got answer as 1305 Newton per mm square. Okay, now we know FPB value. Now find XU value with the help of table. Okay. Now we got answer as FPB into FPB divided by again FPB into FP divided by BD into FCK. We got answer as 0.23, but we don't know 0.23 corresponding value. Again with the help of the interpolation we find the XU by D value. Okay. For 0.23 corresponding value is 0.435. Again 0.25 corresponding is 0.542. Okay. For 0.20 corresponding value is 0.435, but we want 0.23 corresponding value. Okay. Next 0.25 corresponding value is 0.542. With the help of the interpolation we find 0.23 value. Okay. Therefore 0.435 plus 0.435 minus 0.542 divided by 0.25 minus 0.20 into 0.23 minus 0.2. We got answer as 0.50. Okay. Now we got xu by d value as a 0.50. Now we want xu value. So xu equal to d into 0.50. We got d as a 400 into 0.50 and answer is 200 mm. We got xu as a 200 mm. Step number 2. Step 2. Calculation of flexure strength of beam. Okay, M equal to FPB into AP into bracket open D minus 0.42 into XU. Okay, we got FPB value as a 1305 Newton per mm square. Okay, FPB value is 1305 into AP value is given question 500 mm square. 500 into bracket open D as a 400 mm, 400 minus 0.42 into XU as a 200 mm. We got answer as a 206.19 into 10 raised to 6 Newton mm or 206.19 kilonewton meter. This is the final answer. Okay, remember one thing, all the formulas are given in code book.